Welcome back. Our next topic in this lesson is variables. In the last section, we talked about using Python to calculate values. But what happens when you want to save that value to use it later? Well, in that case, you can use a variable. A variable is a name attached to an object that can be called on later. For example, if you do a little bit of math with Python, so you do 2 plus 2, you get an output of 4. Anytime you want this piece of information, this 4, you would have to redo this calculation. If instead you save it as a variable, done here by putting a variable name and setting it equal to the information you want, you can save it for later to do further calculations. So here I multiply it by 2, and instead of having to go back and do this 2 plus 2 again, it just has that information already stored. In a previous lesson, variable names were discussed, but I think they're worth going over again. So variable names can only contain alphanumeric characters, meaning A through Z or 0 through 9, or underscores. They cannot contain spaces. Instead, a lot of people use an underscore as the space if they need to. Python cannot have variables that start with numbers. In that case, you will get an error. Variables in Python in general are case sensitive, meaning that you have to be aware of capitalization and how you type your variable name. One case to avoid is camel case. So that's when you have these capitalizations sort of mid-variable when you're stringing together words. Python has a specific use for that, so it's good to avoid using it as a variable name. And this final one is a good guideline. Using informative names can prevent confusion. So only use single letter names if the meaning of it is clear, right? So if you're using G for gravity, that's probably fine. But if you're naming every variable x, x1, x2, x5, it's going to be hard to keep track of all of them. Now, variables don't have to just be numbers. Any object that Python can create can be saved as a variable. So we're going to discuss a little bit about type of objects in Python. Today we're going to be discussing numbers, Booleans, and strings. And we're going to get to structures in a later lecture because it's a little bit of a larger topic. So there are 3 types of numbers in Python. First, you have an integer, which is a whole number without decimals, right? These can be any size, so you have sort of a small, medium, and large here. But you notice that none of them have decimals, so they're all whole numbers or integers. On the other side of that is a floating point number, or a float, and that is a number containing at least 1 decimal. So in this case, you have 1, which is the same as up here, but because it has this decimal, it's a float. Here you have a decimal with a lot there. And also included floats is the scientific notation, right? So you have 12e15, and that's the same thing as writing 12 times 10 to the 15th. The last type of number is a complex number, which is just a number containing an imaginary part. So in this case, you see 1 plus 1j. J denotes the imaginary part of a complex number in Python. Now, any of these numbers can be negative and so be variables. And you can also use the same arithmetic operators that we learned in the previous section, meaning you can add, subtract, multiply, divide, exponentiate, take the remainder, take the floor of any variable. And you can do it using the variable names instead of the numbers that are attributed to the different variables. But say you have a number and you want to alter it, but you don't really care about saving the original value. In this case, you can change just that number using an assignment operator, shown here. You can see that it's basically just the arithmetic operators with an equal sign afterwards. So going through how this works, you create a variable here, right? I have created my number 3 is equal to 492, and say that I want to add 10 to this number, but I don't care about saving 492. Well, I can do my number 3 plus equals 10, which is the same thing as writing my number 3 equals my number 3 plus 10. This will overwrite the original number and save the new one in its place. So now my number 3 is 502. Now, numbers are the fundamental building blocks of the world. They're an essential part of data analysis computing, and our general understanding of the world. In oceanography, we rely on numbers to explain, quantify everything we know about the ocean. This table here shows just a small sample of, you know, measurements and calculations that would count as numbers in oceanography. So you have time, temperature, salinity, and you get into sort of chemical things with chemical composition and oxygen levels. All of these are numbers. So it's pretty essential that Python has numbers as objects if we're going to be doing data analysis, right? Now, notice that all of these also have units on them. Once again, units are important because then you sort of know what you're quantifying. Moving on to Boolean objects. Much like an on-off switch, Booleans only have two forms, true or false. You can assign variables with these values. Notice that you have to capitalize in order to assign these values. That's just how you create these objects. You can do arithmetic with them, but it just changes it into an integer. So it just changes them into ones and zeros, ones being true, zeros being false. So you can do regular old math with them, but it doesn't always tell you much where you have 1 times 4 plus 0 just equals 4. Booleans are most commonly found as outputs for comparison operators, which are shown here. These are ways of comparing different numbers or different objects with each other. So going through these, we're testing if 5 equals 5, which we know to be true. And notice that this test for equal has two equal signs. If it was just one, Python would think that we were trying to create a variable, and that just can't work. In this case, we're testing that 5 does not equal 5. Since it does, the answer is false. Here, we're testing if 4 is greater than 10. Again, false. We test if 14 is greater than or equal to 10, which is true. And here we test that 4 is less than 10, which is true. And here we test that 10 is less than or equal to 10, which is also true because they are equal. An example of when this can be used is for comparing temperatures. If you type in Seattle average monthly temperature into Google, you'll get a table with the monthly average temperatures. And here I've selected out just a few months to sort of showcase. Now, I assign each month a variable. Temperature in May is 63. Temperature in June is 66. Temperature in July is 72. And the temperature in August is 72. And then I run a few comparisons, right? So here I test if the temperature in May is greater than or equal to the temperature in June. Python says false, and we know this is true because 63 is less than 66. Now here I test if the temperature in June is less than the temperature in August, which we know is true because 66 is less than 72, and Python also prints out true. And then finally I test if the temperature in July is equal to the temperature in August. We know that 72 is equal to 72, and you can see Python does print out true. So this example is really showing how temperature changes and on average over the course of the summer. And the really useful part of these comparison operators and these Booleans is that we can examine sort of how the world changes in time and compare different objects, which is really important for data analysis. This concludes the video for part 2 of lesson 2. Go ahead and take a moment before going on to the next video if you need one, and I'll see you in the next video. We're going to be talking about strings.